Oh yeah, yeah.
What is that?
Yeah.
I thought there's only 6 equations.
There are 6, but there's also integral. Okay, so but I'm gonna show you a good news. So I'm gonna write all 10 equations. So bear with me. So if I take a derivative of the arc sine, also known as what? What's arc sine also known as? Inverse sine. So arc means inverse. Okay. And dx of arc 10 of u is equal to u prime over 1 plus u squared. And the rest of them, I'm still going to show you, but I write in green, blue. Sorry, I'm colorblind. No, I'm not. Arc secant of u. Now this one is going to be u prime over absolute value u square root of u squared minus 1. And then d to the dx is arc cosine of u is going to be negative u prime over square root 1 minus u squared. So it's actually not hard to memorize arc cosine. It's just negative of arc sine. I don't know if you see what I'm saying. See, this is negative sign. This only thing that's different. D to the dx of arc cotan of u is equal to negative u prime over 1 plus u squared. And d to the dx of arc secant of u is equal to u prime over absolute value u square root of u squared minus 1. Negative. Do you see that negative sign there? It's just a relationship. So you know first 3, you know the last 3. But the problem is you don't need to know the third one. You only need to know this one here. I put a 2 asterisk mark, and this one I'm going to put at 3 asterisk mark. Because in term of tasks, now why did I teach this last day before spring break? Am I worried about you're going to forget? Well, I don't really worry about it because the time that they're going to test inverse sine and inverse tangent trig, it's only 5% of chance to 10% of chance. Really, really minimum chances that they will ask this. Because this subject usually teach in Calc 2 in Valencia or UCF. So you don't have to really, really significantly worry too much, but at a minimum, you need to know this one. This one is going to happen almost 60% of the time, and this one's going to happen maybe 30% of the time. Now, 10% of the time, it's going to be the other 10. Now, remember, there's only 5% of chance that this will show up on the test, or 10% of chance it will show up. So almost not needed to worry about the blue one. The blue one's almost insignificant. So then you say, how do I use it? Well, it's pretty easy. So if I were to d to the dx of sine inverse, now why did I write use sine inverse? I want you to recognize sine inverse are the same thing as arc sine. So arc sine of x is equivalent to sine inverse of x. So those are the things that you should understand. Once you understand those, you'll be doing good. Okay, so I'm going to ask you to take a derivative of this. But this one's actually super easy. The way to think about it is, think about this as some type of junk. We're going to call this junk u. Then all we're going to do is do u prime on the top, which is 2, over square root of 1 minus 2x squared. Now, make sure you put a parenthesis around 2x, because you don't, you think it's a square root 1 minus 2x squared, but it's not. It's actually 2 over square root of 1 minus 4x squared instead of 2x squared. Is that hard? Super easy, right? Just have to follow the formula.
just the full answer.
That's the answer. Okay, so I'm gonna ask you to try two of them. If I'm taking d to the dx of arc 10 of 3x, and I'm gonna ask you to take d to the dx of arc sine of square root of x. Can you give me an answer on both of them? All you need to learn is learn how to use a formula. You have to memorize arc 10 because arc 10 is almost 70% to 80% a chance it's going to be tested if they did test it. Arc sine is almost like 30% of the time, so it's okay if you don't know how the arc sine works, but knowing the minimum arc 10, and that's the things you gotta do. So I want you to take a derivative of this, arc 10 of 3x, and the other one I want to take arc sine of square root of x. You already done? That was quick. She's like, I learned this in Los Angeles. Well, which part of Los Angeles do you live in?
Say it again.
Which part of Los Angeles do you live in?
Technically, it's not Los Angeles. It's a city next to it in like a big county.
Where?
Santa Clarita.
Santa Clarita? Is that next to the beach?
It's like an hour away.
Is that a rich neighborhood? No? Sounds pretty rich.
I mean, it's a nice city, but I did not live in a rich neighborhood.
Yeah, but California, everything expensive, especially land.
Hey, look, someone posted the gas prices yesterday, and it was $5.40. Like just regular.
Yeah, here it's still $4. Yeah, California, like LA is like California is actually going really bad. Like now, now it's actually a well-run state. It's actually a Republican state, like Texas and Florida.
Yeah.
And all the liberal is too woke. I think too much. I mean, you can be woke.
They're intense.
Yeah, they can be woke, but they should not be like this much. Like, okay, you're anti-abortion. Yeah, okay, fine. But if you like something like extreme, I think that's too extreme. I think you need to be somewhere in balance again. I really think that it should not be too far right.
Yeah.
It should not be too far left. But again, not marketable. Okay, so first one is u equal to 3x. Did you do that? And u prime is going to be 3 over 1 plus 3x squared. So let's do 3 over 1 plus 9x squared. It's not 3 over 1 plus 3x squared. It's 9x squared. See how did you do it? Does that make sense?
Yeah, I think I switched it. Oh wait, I made a mistake. I switched it like I did the opposite. Like instead of doing tan, I did sine.
Oh, okay. So this is arc 10. Okay, so that's a arc sine. Well, arc sine, again, u is equal to what?
Or x to the 1.
X to 1 half. Good. What is du?
-1.
1 half x to the negative 1 half? Or 1 over 2 square root x, right? So eventually it's going to be 1 over 2 square root x times 1 minus square root x squared. So 1 over 2 square root x times 1 minus x. Does that make sense? You can distribute the square root x because they both have 1 half power. So that's able to distribute. So that's going to be x minus x squared. And that's the final result of that. Huh?
Oh, it's sine. Oh. Genius.
Yeah, you just have to follow the correct formula and just do the things that you do. And then that. This is hard. It's very, very direct. It's like you just follow the formula. Next thing I'm going to show you is the integral of this. So how many equations you have to know? 4. Total 4. You already learned 2. You're going to learn the other 2. But there's actually 3 here, but you only need to know 2. So which 2? Well, I'm going to write down all 3 though. Integration of du over square root of a squared minus u squared is equal to arc sine of u over a plus c. Look very similar. Instead of 1 square, it's going to be a square. And the a is going to become on the denominator. That's the way it is. The second one you need to know is du over a squared plus u squared. This should look familiar as well. It's going to be arc tan of u over a plus c. Now, instead of this one, you're going to have 1 over a here, that unlike before. So again, the things that you might get asked is those 2, but not the last one. The last one is du is not significant. U square root of u squared minus a squared is equal to 1 over a arc secant of absolute value u over a plus c. This one don't need it. I will just memorize those 2. So total formula you had to memorize today. 4. 2 for derivative, 2 for integration. And then if you understand 4, now you just have to use it. So again, with this type of situation, you need to find 3 things. If you find a squared and u squared, you should be able to lead to what is a and what is u. Okay, so basically, if you see the a squared is u squared, then just square root both sides, you're going to get a and u. Also, the most important thing, once you get u, make sure find du. Make sure you find du, because that might give you a very, very important asset. So I'm going to show you how to take integral of this. If I have integral of dx over square root 4 minus x squared. So first thing, you have to recognize something. Can I use U-substitution here? Yes or no? And why yes and why no?
Yes.
What would you want the U equal to? If yes. Huh?
You know, because you can't cancel out u.
Exactly. So you point out something very valid. Your first idea always do U-substitutions, right? And then your U-substitution, probably your first try is going to be u equal to 4 minus x squared. But the problem is du is going to be negative 2x. But the problem is negative 2x has nothing for you to cancel. So therefore, U-substitution will not work. Now, what you're going to do is you're going to do inverse trig integration. Now, inverse trig has U-substitution. It's just the way the U setup is different. They're going to say, well, they're going to say u squared is equal to x squared. And a squared is equal to 4. Well, what is u? X. And what is a? 2. And then also do one more thing. This one's going to be careful. Du equal to dx. So can I rewrite this is du over square root a squared minus u squared. Or in this case, it's going to be arc sine of u over a, which is x over 2 plus c. And that's it. Done deal. Does that make sense? Okay. Last one. This one's kind of hard. I don't think anybody gonna get it right. I'm hoping that some of you guys can prove me wrong, but so far nobody got it right. So I'm gonna say integration of dx over 2 plus 9x squared. And they say, hey, can you tell me what's integration of this? Well, which formula does this one look like? That's the first thing you should ask yourself. Second equation, second thing, you had to say u squared equal to what? A squared is equal to what? You can find out what a u and a. Once you find a u and a, it's not end of the course. The last hardest part is you want to take a derivative, and the derivative of the u, you're gonna get du. So that's the part that you guys all mess up that part. So why did I say so far not a single person got it correct? Why? Make sure you follow the formula too. The formula is right here. How many guys are done? Cool. If you're done, can you tell me what your answer is? I'll tell you it's right.
I got 3 over square root of 2 arc tan of 3x over 2 plus c.
Can you say that again?
3 over square root of 2 times arc tan of 3x over 2 plus c.
It's off a little bit. But square root of 2 is a good idea. Anybody else want to give it a try? Well, I'm going to do it here. A squared is equal to 2. Does that make sense? Yeah. A's must be 2. Does that make sense? Square root of 2, sorry. U squared is equal to 9x squared. What is u? 3x. Did you take du? Are you sure?
Oh.
And did you solve for dx? There'll be du over 3, right? So therefore, it's going to be du and the 1/3 in the front. I hear it's going to be a squared plus the u squared. Now we say it's going to be 1 over a first. So 1 over square root 2. Did you do that? And the arc tan of u over a. So arc tan of u over a, so which is 3x over square root 2, right? Plus c, but there's 1/3 in the front. And most of you guys forgot that 1/3.
Distribute that 1/3?
Because that 1/3 is in the front, you had to place it here. Yeah, so that's the thing. So you gotta be careful.
Is it 1/3 times 1/√2?
Yeah, so 1/3 square root 2. Do you have to rationalize? Not necessary. In this case, it's fine. I mean,
Did it right, Mr. Yuna?
you did it?
I did.
Okay. Impressive. First one in the day.
You should get a prize.
I should get a prize. No, you shouldn't.
Okay, so your homework is gonna base on those integration and things like that nature. And you know, they are pretty easy. They're not something more difficult, but it gets more difficult when you have a definite integral on this. But what I'm gonna do is I'm gonna show you a proof why derivatives that way. Okay, let me show you a proof why it's derivative that way. I'm not showing the proof of integral, but the derivative. So y equal to the arc sine of x. I'm going to show you the proof. How do they come up with the square root of 1 minus x squared? It's so confusing, right? But then you say, okay, well, I'm going to show you how this happened. Can I rewrite as a sine inverse of x? You know that's equal to each other, right? Can I do this? Sine to the both sides. And this cancel out. Yes, right? Do you remember SOHCAHTOA? Huh?
I found it in SOHCAHTOA.
What?
SOHCAHTOA. My geometry teacher said it was some old hippie caught another hippie slipping on plastic.
Actually, that's the second time I hear that. It's pretty cute. So the things about this is if you have this situation, it leads to a right triangle with the angle y, with this angle y, and then it has opposite, which is x, and the hypotenuse is 1. Does this make sense? If you have that ratio, you will have a right triangle with the y as an angle and opposite as x. Hypotenuse is 1. Are we okay here? Now we're gonna also name this side as z because we don't know what z is. But we want to find a z in terms of x. What does that mean? You're gonna have x squared plus z squared is equal to 1. And then z squared equal to 1 minus x squared. Z is equal to square root of 1 minus x squared. So this one square root 1 minus x squared. So now let's do a beautiful part of this. Let's take a derivative of sine of y. So I'm going to take a d to the dx on both sides. There's an implicit derivative happen. So it'll be cosine of y times dy dx is equal to 1. Does that make sense? That's just an implicit derivative. I'm going to show you dy dx is equal to 1 over cosine of y. But again, what is cosine of y? Well, cosine of y is what? Adjacent over what? Hypotenuse. So that's going to be 1 over adjacent is square root of 1 minus x squared over 1. So the answer is 1 over 1 minus x squared. So that is an actual proof where they come in play. It's very clever. Like, who come up with this shit? I don't know. Mathematician. They are super genius. They're very creative. A great mathematician. Not me. I'm a fake mathematician. I pretend to know math. But the people actually know math. They are actually have the brightest mind, the most creative individual in face of earth. They are very, very creative. Okay. And one perfect example is, like I said before, cryptocurrency is started by mathematicians. And all the people that work in cryptocurrency is all major in math. So cryptography is, decoding and stuff like that, blockchain, it's all idea for mathematician. So a lot of you guys need to learn to appreciate those things, but that's the one thing I actually appreciate. I was like, wait, how did they come up with that when I was a student? I was like, where does that come from? Where's the square root 1 minus x squared come from? It's from there. It's from a damn triangle.